Welcome to Eureka Math. I'm Mr. Schenkel. I'm going to be helping you today with Module 1, Lesson 13. Let's get started. So today we're going to be comparing large numbers, and we're going to try to decide which one is bigger or smaller. So let's try exercise 1. The Fornax dwarf galaxy is 4.6 times 10 to the 5th light years away from Earth, while Andromeda 1 is 2.430 times 10 to the 6th light years away from Earth. Which is closer to Earth? Well, the best way to do this is to make both of our powers of 10 the same, and then compare our numbers. So I could change the 10 to the 5th into 10 to the 6th, or I could change the 10 to the 6th into 10 to the 5th, and we're going to do that one. So we have 4.6 times 10 to the 5th, and we want to rewrite our other number, 2.430 times 10 to the 6th. We want that to be something times 10 to the 5th power. And since my exponent is going down, this number has to go up. So we get 24.30 times 10 to the 5th. And now you can see that on our Andromeda distance, we have 10 to the 5th, and then we also have 10 to the 5th over here for the Fornax dwarf galaxy. And since they're the same, then we just have to compare the two numbers here. So this 4.6 is less than 24.3, so the one that's closer to the Earth is the smaller number. So this is the smallest, and that means the Fornax dwarf galaxy is closer to Earth. So that's simple. As long as we can make our power of 10 the same exponent, then we just compare the other numbers that we're multiplying by. All right? Exercise 2. The average lifetime of the tau lepton is 2.906 times 10 to the negative 13th seconds. That's not very long. And the average lifetime of the neutral pion is 8.4 times 10 to the negative 17th seconds. Which subatomic particle has the longer average lifetime? Well, I've got negative to the negative 13th, and I have negative 17th powers. So I need to change either one of those. So I guess let's just do this. Let's go 2.906 times 10 to the negative 13th, and our other is 8.4 times 10 to the negative 17th. And let's see, I wrote to the 3rd, I meant to the 13th. And let's change this one to the negative 17th power. So I want this to be times 10 to the negative 17th power. Looks weird. Negative 17th power. So that means I have to make this smaller by 4. So this has to be bigger by 4. 1, 2, 3, 4. Decimal goes here, and I fill in zeros. So I get 0.002906 times 10 to the negative 17th, and then we have this in the 10 to the negative 17th power, and this one's already there. And then we just have to compare the two numbers preceding the power. So I know that 0.002906 is definitely less than 8.4. So which one has the longer lifetime? Well, that would be this one. So that is the neutral pion. All right. Exercise 4 is next. We're going to compare 9.3 times 10 to the 28th and 9.2879 times 10 to the 28th. This is nice because I have 10 to the 28th in both numbers. So I just have to compare the first two numbers of each, and so I get 9.3 is greater than 9.2, 879. So there we go. The first number is bigger than the second. All right, that's good. And one more, exercise 5. Chris said that 5.3 times 10 to the 41st is less than 5.301 times 10 to the 41st because 5.3 has fewer digits than 5.301. Show that even though his answer is correct, his reasoning is flawed. Show him an example to illustrate that his reasoning would result in an incorrect answer. All right, well, yeah, he is wrong. It's not because of the number of digits, because we can compare them, first of all, before we talk about that, because they're both 10 to the 41st power. So 5.3, if we think on a number line, if this is 5 and this is 6, 5.3, if I split it into 10 equal pieces, tenths, would look something like this. 5.3 would be here, so that is 5.3. And then 5.301 would just be a little bit farther to the right, maybe, somewhere in there. So 5.301 is a little bit bigger than 5.3. And if we think of place value, this will make more sense. If we think of place value, this is 5 and 3/10, but I could add zeros to match my other number, and now I have 5 and 300 1/1000. 5 and 300 1/1000 is 5.3, so these two are equal. And then 5.301 is actually 5 and 301 1/1000. And you can clearly see now that this one is bigger. Okay, so let's use Chris's reasoning and show him an example where this would not be correct. Well, if I use the same numbers, 5.3, and instead of 5.3, let's use 5.201. Well, 5.201 is going to be a little bit greater than 5.2, somewhere right in there. So now the one with the most digits is actually going to be smaller. I would say 5.201 is less than 5.3. So Chris's logic in saying that 5.3 has less digits, so it's going to be smaller, doesn't hold. This would be a counterexample to show that that's not true. But if you think place value and you make them the same place value, it's easy to compare the two numbers and sizes. All right? That is lesson 13. I hope that helps. See you next time.